Hey guys, welcome back to another episode of Man Time. In today's episode, I'll be putting back together the Century motor that we had taken apart, and we're going to use for the belt grinder. I've got the belt grinder up here. I'm going to take that. I'm going to take you through kind of what that is. It was just a $20 flea market find, but it looks like it'll be pretty cool. No, today's episode was not brought to you by Jägermeister. I just happen to have this shirt, probably from college, and it's black, so when I wipe my grease off on it, it doesn't show up, doesn't stain. Good shirt. So anyways, we'll start in on the motor. Alright, so here we go. I've got the motor all sealed up here. I am super excited to get this thing back together. I've got all of the wiring taped off here. We'll get that tape off of there. See how bad it is. I've labeled everything. A couple of these I should just be able to put right back into this little internal terminal block that's on here. But you can see we've got some frayed wires and things coming out of the back of this. And so what I'm going to do with the ones that I can, it's directly soldered on there. With the ones that I can fix by putting a piece of shrink wrap over, I'm going to do that. And the ones that I can't, I think this one here is about the only one I can get a piece of shrink wrap on. All the others here, oh, that one I can. All the others, I'm just going to wrap up with electrical tape. It's not necessarily a hugely bad thing to tape these old cloth-covered cords up with electrical tape. I hate to do it. Normally I would put a piece of shrink wrap on there, shrink it, and we could go like that. But we will go with what we can do. One other thing I wanted to show you was the old belt grinder. This looks like a 3x24. Now it was in a different configuration. I kind of set it up and just kind of tried to see what would work here with a 24-inch belt. With a 24-inch belt, this has got to be shoved way in, this has got to be shoved way in, and actually it would be making contact with the bottom of this this platen here. This is a Ward, Craft Ward, Powercraft by Ward. Never heard of the brand. Looks like a pretty decent unit. Again, for 20 bucks, what more can you ask for? And then I've got an old stand back here that I built for a welder. I'm going to try to get all this together and piece together and then put onto that stand. Alright, we're back here. I was looking at this centrifuge start, and I found something really interesting on here and how it works. So it's got an area that's really nice and shiny right there, and that's what rubs against this plate on the rotor. So it's going to rub right there, and then as that snaps back, it is going to basically be able to come out. And what it's got is a little contact right in there. I'm going to take some steel wool, kind of shove that in there, and go back and forth and clean that contactor off. But that contactor then connects this with this, and then there's our post on the other side of it, and it makes that connection right there. And it doesn't look like brass, although I would think it would be brass, but we'll get that cleaned up. So it's got a nice smooth contact, and then we'll top it off with a little Vaseline. Yeah, so there it's It's a shiny silverish color. But that is going to engage just for a second, and again, engage the start windings, and then it's going to break off the start windings once it's up to speed with that release mechanism. Yep, I think that's going to work good. Okay, and then a couple schools of thought here with this cloth covered wire. The old school method would have been friction tape, and I've got some friction tape here. Typically what I'll do with friction tape is cut it down the center and then use smaller strips and completely wrap it that way. Of course, the new school method would be electrical tape, and also I've got some Also, I've got, you know, the shrink wrap tubing, which I bought in a kit off of Amazon with a bunch of different sizes of shrink wrap in there. So, again, what I'd like to do is put the shrink tubing on there. I'm going to try that with a few of them that I can, but you can see here some of them are actually soldered onto the back of these connections for the start mechanism. And those, I think I'm just going to go ahead and use electrical tape for. These other ones here that I can get on there, I am going to use the shrink wrap. So, start the fast motion speed play. Whoa! Alright, there's one other method to get way back in here where the wire is coming right off of the windings, and that's liquid electrical tape. It's not the best solution, but it's one way we can get in there and seal off that wire that's frayed out from the from this fabric wrapping or cotton wrapping on there. So let's get some of that on there. Alright, I've got all of our wires sealed up in here. Got electrical tape on some of them. Got our shrink wrap on others. I've got some liquid electrical tape down where they're coming right from the windings there. Next thing I wanted to check was the capacitor. And it had this little stopper and had this pressed down into there like that. I was testing it for capacitance and I didn't get any reading, so it was open. It was an open circuit where it should be closed with some amount of resistance, and the resistance should start somewhere and then drop eventually to nothing, or thereabouts. So after I figured out that that wasn't happening with the ohm meter here set to resistance, I went ahead and popped this little keeper off, and since I'm working outside, I should be fine. But you can see here that was a capacitor back then, and these are actually carcinogenic. There's a carcinogenic fluid inside of there. It looks like most of this one is gone. So, at any rate, I can't read or make out the capacitance on here. All I can make out is maybe a General Electric part number, and made in the USA 188772. Yeah, there's essentially no useful information on here that I can make out as far as capacitance. Yeah, nothing. So, I've got some capacitors I'm going to hook into this circuit here, and we can just try some different capacitors to try to match the capacitance of this one here. Okay guys, we're back. I did happen to find this Gentech. I have this one as a backup for the blower in the AC for the house indoor unit, and it just so happens to fit right in the stock cover here. So I should be able to hook this up. There we go. There. And then I can tilt it up on its side, maybe. And it's going to be kind of a tight squeeze. No, that'll work. Alright, so I've got that hooked up. I'm just going to do some preliminary checks of resistance here. See what's what coming through the motor. 3.9, 3.8. That seems a little low, but then again, see that one's dropping? I don't know if you can see that. That one is going to be running through the capacitor. 4, 3, yeah, it's just jumping all over the place. So that one's going to be basically what we would expect to see coming through the capacitor as well. Or OL. There we go. Okay, so that was the same. It started off high and then it just continued to drop down. That's good. That's what we would expect to see there. I don't know what. We've got some frayed wires, really frayed wires, coming into this connector here. I'm going to have to change out this connector. When I tested on the connector itself, it said OL, no reading. All the wires are frayed going into this connector. So I'll get that changed out before we start anything. Okay, you can see right on top here, I've got a blue connector. I was having some length issues. Both of the connections on here that went to the capacitor were, there was frayed wire on both of them, so I went ahead and decided to go ahead and just replace both of the connectors on the end of this wire here that's going to go to that capacitor. And I'm going to shove a little piece of friction tape in there as well, because I've got some fraying on the cloth wrapping around there. And what I'm just going to do here is kind of ball this up and then shove it in between there, just to give it a little extra protection from arcing across. That's not going to work. One nice thing about being a hay farmer, there's no shortage of baling wire laying around. we go. Just get a nice separation between those two wires. It's got a rubber grommet on there. The grommet's in good shape on both the top side and the bottom side. And we'll just give these wires a good twist and connect them into these connectors. And one thing, there we go, perfect. One thing I wanted to show you here, guys, is a tool that I bought not too long ago. And this one is a something called a commercial electric brand. And I think I got these from Home Depot. Don't get a pair of them. They're bad. They're made in China. I thought they were really cool because they had this double feature where you can flip them around, get yourself a crimper on one side with a plier, and then get your stripper on the other side, right? Looks like an awesome tool. I mean, it's got this nice nickel finish on it. It's got your gauges on it. Very, very nice stripper. But when you go to use your crimp side, it deflects and it does not crimp on center. And it screws the crimp all up. So I use them for the stripping purpose, but that is it. So for the crimper, the best one you can get right here for a wire crimper. This one is unbranded, but it'll have these red handles and just a really nice crimping unit there. And you use the crimper that's got that big detent area, and that's going to crimp your wire really nice and tight. Okay, so when crimping wire, come in just inside of this flared out area. So you're going to come just inside of that. And you'll hear it kind of mash down into the wires. That's a good thing. Okay. Why not, right? I'll have to order myself another 5 microfarad capacitor here, but 5 microfarad, 370 VAC. So that'll fit on there real nice. All right, let's move on to attaching the cover here. I'm attaching this to the cover. Oh, first of all, petroleum jelly. This acts as a dielectric lube right in here on our contact. And we'll just mash a bunch of this inside of there. Now that's going to keep the corrosion off of there. And it's going to provide a clean electrical mating surface. Oh, it's kind of sticking there. Don't want it to stick. So I might have got a little too much in there. Try that. Too much. There we go. Okay. Before I do that, I've been spraying inside of this what they call a bearing or a bushing, Most of these old motors, they called their bushings bearings. So this is going to be a brass bearing. I'm going to take some Berrymans and I'm going to spray down and just flood this whole area. It's pretty difficult getting these sealed caps off of here, and what I've found is I have just better luck hosing it down with some carb cleaner or some Berrymans carbon choke cleaner, and just flushing all of the old grease and congealed oil out of there. And like I said, I've had it soaking with PB Blaster. I've flooded it with PB Blaster already, helped break down some of those congealed fluids, and now I'm just going to thoroughly rinse it with that Berrymans, and then we'll come back in here, attach this like so. All right in there, and then we can get our back cover on there. We'll get our rotor in there, get our front cover, hook some power up to it, check it, and see where we're at. I went ahead and used my my Berrymans chem tool, and I flooded out inside of this bearing here. It's tough to see, but there's a packing inside of there, and it'll be inside of this well here, and that will hold lubrication or lubricant for the bearing and for the rotor shaft. Alright, so next step, and these old Century motors are just fantastic examples of a really good motor. Okay, got our junction block in there now. Alright, next step is going to be to see how this thing was in there. Now, whether it was like this, and these were all just kind of shoved. Yeah, I think that's how it went. Okay. So the next step is going to be to take our motor bolts, find out where those are going to run through here. Line a couple up. Two. Okay. All right, now I'm going to grab a brass or no-blow hammer, tap that around there, get the front cover on here after we put the rotor in there, and then we'll get some power to her, see what she does. That's good. Yeah, you saw me using this claw hammer. This is actually a really cheap, I think it's probably a Chinese. It's non-heat treated. It is super soft. So I use this a lot of times in the place of a no-blow. I do have a really nice Proto, but with a nice light touch, you can do the same work with just a regular soft claw hammer. Okay. Beautiful. Look at these beautiful windings. These are nice and centered. It's good. Okay, so now we're coming with the, again, the scent start first. And I'm going to take and wipe off anything that might be on there. I'm also going to take, and I've already wiped out inside of the bearing in here. Just want to double check and make sure that it's all clear. Still got some lubrication floating around in there. Okay, I'll do the same out here. And this had this little ring around it. I don't know what that's for, but we'll get that back on there. And you can see here where I've machined in a recess. And actually what I'm going to do there, I'm going to go ahead and put some petroleum jelly in there. So it'll hold some lubrication inside of there. And petroleum jelly was the go-to lubrication back in the day. So we'll put some of that on there. You know what, let me get a little bit on the rear end of it also. Okay. Alright, so now we need to line up top and top. And we know the top is where our oil or grease adder flip cup is there. And we'll match up top to top with the grease cup adder. And then as we come in, we'll line up our bolts. Beautiful. Yeah, before I started putting this back together, I took a wire brush and cleaned all of the mating surfaces. This is one of the handiest tools to have on hand, because, and then we'll put this little spring. It had a little spring on the front of it here. I don't know what the heck that's for, but we'll put it back on there. Why not? And the reason I say that these are real handy to have around, I have one of these in every toolbox. I have one in every cart, because when you're out in the field and you need to clean out your threads, it's perfect. It's also perfect when you need to clean your mating surfaces. And what I mean by mating surfaces, the surface on the inside edge of this rim here from the motor housing and the outside rim of your actual motor here. When those mate up, you've got two surfaces coming together that want to be a machine fit or a precision fit. Well, if they've got rust and dirt and grime on them, they aren't going to seat up and have a perfect parallel. You know, you might have some gaps in there with some dirt and debris. So your wire brush, first clean all your mating surfaces, clean out your threads, and then we can go to reassembly. Let's start getting everything buttoned up here. I have got my 7/16. Give all these bolts a nice snug. Checking on the back side, making sure that that through bolt isn't turning. Yes. Okay. Oh boy, I'm getting excited. Son of a gun, I forgot my Allen wrench. Got a little too excited there. I got some automatic transmission fluid I'm going to fill up our oil wells with. Got to remember which one of these worked. That's not it. Yeah, Greenlee still makes a really decent set of Allen wrenches. So if you're looking for a good set, I can recommend these. I've been using these for a while. They're far and away better than the Harbor Freight brand. So I'm just going to drive this down into that keyway until it bottoms out. Check our motor play. I'm seeing about a 1/16 of an inch. Boy, that's spectacular. Man, when this thing kicks on, that is a lot of rotating mass. A lot of rotating mass. This thing is gonna jump when it kicks on. Okay, so I've got automatic transmission fluid. I'm gonna spray down in here. And that is just gonna drink it up. Okay. Very nice and smooth. Okay. Last but not least, we'll get our leads hooked up. I've got a dummy wire over here, and we'll just come in there. Clean these up a little bit here. I'm missing some wire. It's been a while since I've cleaned these up. Strip off a little bit of new wire here. With the nut. So I've got the hook coming in this direction. You can see the hook is curved this way, and the nut is going to tighten that way as well. So when I bring it in and hook it around the stud in here, it is going to help it self-tighten as I tighten the nut down. And you just want to make sure that your wire is staying inside of where that nut is at and not trying to squish out. So there we have it. Oh boy. This is the moment of truth. This is it. So I've got my kilowatt meter. I'm expecting to see a ramp from the kilowatt of maybe 10 amps. Probably also expecting to blow a fuse due to that. I've got a 15 amp circuit, but you just never can tell. Okay, so this is either going to kick on or it's going to go up in smoke. There's no on or off. I'm powered directly into the motor. I've got 122 volts. I'm going to switch to amps on the kilowatt and pray for rain. Oh, I've got humming. I've got 9.34. Oh my goodness. I've got the scent start kicked off. But look at there, I'm only running at 1.32 amps. 1.32 amps. This must have been wired for 220. The slow startup, the super low amps, it's going in series through all those windings. So I'm either going to have to rewire it inside the motor, or I'm going to have to hook a 220 or 240 plug to it and run it off of 240. But look at that, 1.3 amps. It's spinning. Silent. Dead silent. Wow. It's a thing of beauty. I dug this motor out of the ground. Literally dug it out of the ground. And it is purring along like a kitten. Oh, you're amazing. You're amazing, old Century motor. A little bit of hard work, a little bit of grease under the fingernails, and we have a fully functioning motor. It's going to work perfect for our little belt sander, and I'm just going to wire it up for 230 and run it as it's wired here. I can plug 230 directly into our line connections on that terminal block. That'll boost our amperage up, that'll boost our starting torque up, and it is going to be phenomenal. Let's listen to that start switch. You'll hear it. There's the start switch. Oh, it's functioning perfectly. Perfectly. Listen to that again. Let's do a startup and listen to the start switch disengage. Again, not enough starting torque. We're wired to run at 240. Little push start. There goes our start switch. The centrifuge uses the centriforce or centrifugal forces to disengage. Running again right there, 1.3. We'll unplug. And as our spin down slows, that centrifuge start loses its forces or momentum, holding it open, and it will close back up. There it goes. Oh boy. Alright guys, thanks for sticking around. This has been another excellent episode of Man Time, if I do say so myself. We got our hands dirty. We worked on an electric motor. We got it all put back together. After taking it apart, going through it, revarnishing all the windings, putting some tape and making it safe around the leads and the winding leads, and it runs phenomenally. I'm gonna have to get 240 hooked up to it. I'll test it then for amperage, and we will see how good it does at 240. But by hooking up the 110 and determining that the amperage was too low, the starting torque wasn't enough, that led me to realize that it was wired actually in a series wind inside of the motor. That draws a lot more of your current down, so your amperage is lower doing it that way. If it were internally wound for 120, it would have been in a parallel, where you would have two of the opposing windings wound together, and it's just a different setup there. But thanks for joining me. Hope you enjoyed. Stay tuned for the finish of the 3x24 belt grinder with the new motor that we just dug out of the ground and rebuilt. Thanks for staying with me.